Right, in this practice paper, many of you got this right, except the following three questions. So these questions are 27, 41, and 42. So let's go and take a look. So here we're given an equation of a circle and a diagram. And the question asks which of the following must be true. So we need to check each of the statement one by one. So first of all, statement 1. And this statement means that x is 0, y is 0. That's why we get h squared plus k is a square and equal to r squared. So let's assume there's a center. So at this point here, we see that the radius is r and the center extending to the point of the origin 0, 0, which is x is 0, y is 0. So the distance here is r. So if we drop a perpendicular line and we look at a right angle triangle, so the distance that we have now is h and k. So in this case, we use Pythagoras theorem. The statement 1 is true. So let's look at statement 2. Now here we see that k is bigger than 0 because the y coordinate is positive. However, the coordinate of x is negative, i.e. h will be less than 0. So the statement 2 says h minus k. So I have actually a negative value minus a positive value. And the result of that is minus another value again. And that will still be negative. So hence statement 2 is true. So let's look at statement 3. So by looking at a right angle triangle that we have formulated, r, k, and h. So by looking at this, we see r is the hypotenuse. So therefore, the sum of any two sides, the other two sides, must be bigger than r. Otherwise, we won't have a triangle. So statement 3 is also true. So the answer here is D. Okay? Right, now, question 41. We have a pyramid, and actually the base is a equilateral, where it's a regular pentagon, and all the triangles actually are equilateral triangles. And we want to find the angles between the two planes. So let's take a look. This is one plane, and being equilateral triangle, all sides are equal. And here's another plane. Now to find the angle between these two planes, we drop from the vertex, and in this case for the triangle ABV, vertex is at A, to the adjoining line, which is BV. And again, on the other vertex, which is at C, drop another perpendicular line to the adjoining line, VB. And then that's the angle we're looking for. So here then, at the point P, so we're looking at an angle of APC, and that's the angle between the two planes. Now we know being an equilateral triangle, all the angles then would be of 60 degrees. So let's take a look at one of the triangle, ABP. So now that we know that the angle is at 60 degrees, we could express this in the trig ratio and find the length of AP. Now here, AP is actually equal to root 3 over 2x. And this is actually the same as with the other side of PC, because they're both identical equilateral triangle. So AP actually equal to PC. So let's look at another triangle of ABC. Now, the triangle ABC on the base, we want to find the length of AC, because if I know that, then I could find the angle of APC using the cosine rule. Now, the base angle here is actually an interior angle of a regular pentagon, and we could find the angle by knowing that the interior angle of pentagon is the sum of the interior angle divided by n. So hence, if we work it out, the angle here is of 108. So therefore, AC squared, using the cosine rule here now, hence AC is now equal to this. So I'll put this back onto my triangle on top and find the angle between the two planes. So I'll let the angle between the two planes be W. Now the algebra here may look awful, okay, but it does give you hints. Now we may not be able to work it out, but by eliminating some of the possible answers, we will arrive at the correct answer. So now we can say that cosine W is of the expression on the left. Now note first, what you end up with is actually the negative cosine W. So cosine W actually is a minus a value. So being a minus a value, we see that A will be out, because B minus it will be at the second quadrant. So B is out. The only two possible answers here is either C or D. Now, but if you take a look at the base of in this regular pentagon, we know that this angle here is of 108. So if you imagine if I move it up like that, then this angle at the point of P will change, vary, may not necessarily be 108. And actually it cannot be 108, because if I move this along the line of BV, any moving point along here, the angle that I create, it will only be 108 if it's at the point of B. So in this case then, we can rule out the possibility of C. And the only answer left now is of D. So answer here is D. Now in this question 42, we are given two identical circles. So being an identical circle, then we know that the center is on the same line. Okay, their centers are aligned with each other. And also we know that AB is a tangent to the other circle. So let's put that information in. So imagine there's a center O, then the other center then must be O dash. Now at this point here, what I've done is that the R is the radius of the circle on the left and links to the center O dash on the second circle on the right. Now by joining this, we now know that actually this forms an equilateral triangle. And also note that because AB is a tangent, then the angle from the tangent to the center is actually perpendicular. Okay, so radius perpendicular, tangent perpendicular radius. Okay, so we have a 90 degree. So in here then, we now know these angles, they will all be of 60 degrees. Now by looking at this is 60 degree, therefore the angle on the left of this, which is angle AOP, is of 90 minus 60, which gives me 30 degree. Now the angles on top actually is a angle created from A, extended through the center O, to the point at the circumference B. So this angle here of ABP must be half the angle at center. So we are saying that angle at center is twice the angle at a point on circumference. Hence, B will now be 30 degrees divided by 2, which is our 15 degrees. So the answer here is C. So thank you for watching. If you have any question, please email me or find me in staff room B. So let's carry on. Alright, we will have another set coming up. So keep going. Thank you for watching. Bye for now.